Oh yeah, for sure.
Okay, so let's go ahead and get going with section 3.3. We're going to talk about graphs of polynomials. So some of you who were telling me how excited you were about the graphs on the test, you're going to, obviously really love this as well because it's graphs. But hopefully we can make it relatively straightforward and hopefully easy to remember how to do it. It's all about graphs. It's all about the graphs. Okay, so remember, in the past, with all the work that we've done, if we are ever finding an x-intercept, or a horizontal intercept, they call it sometimes, if we're ever finding the x-intercept of a function, we always set the function value, the f of x part, equal to 0, and then we solve. So here's what that looks like. If you've got a function, and it looks like this, f of x equals, whatever. Let's say 3x squared plus 5x minus 2. Okay? If we want to find the x-intercept, we take this part right here, the function value, and we put in the 0. Oh, this is for x. Hang on. Let me put this in the right spot. This is to find the x-intercept.
X-intercept.
Okay?
Is 0.
Okay? So if you're going to find the x-intercept, you replace the f of x part, or the y, with a 0. And then you do the work to solve, whether that's factoring or a quadratic formula. Okay? And we're not going to do that right now. That's just an example of how we would set it up. Okay? If we want to find the y-intercept for a function, we do just the opposite. If we want to find the y-intercept, or the f of x-intercept, we take all the x's and replace them with zeros. That's the easy one, because when you put in all these zeros for the x's, all you have left is -2. So you're done already just by looking at it very quickly. Okay, so the x-intercepts usually takes us some work to try and figure out. The y-intercepts are really easy. You just plug in 0 for all the x's and you get your answer. So that's, again, we're not going to do that problem. That's just how you would set it up to find the x-intercept and the y-intercept. Okay, and we've done those things before. In fact, I think you had something like that on your test where you had to find the x-intercept and the y-intercept. So, are you saying I forgot that part? Okay. All right. So that's just a little bit of review of something that hopefully we remembered. And so let's take a look at how we're going to apply that. So when we look at a function like this, we want to find the x-intercepts. And remember, on the graph, what that looks like is it's where it crosses the x-axis. Those are the x-intercepts. Okay? So all of those points always have an ordered pair of something comma 0, because if you're crossing the x-axis like this, the height above or below, it's always 0. It's just right on the x-axis. So it's always going to be something comma 0. So we replace the f of x with a 0. And my suggestion, if you can, is to go ahead and try to factor first. Your first option probably is going to be factoring, especially in a case like this. So if you can factor, especially if it's easy factoring, it gets done very quickly. So let's look at this. The first thing we should always look for, and it's been a while since we talked about factoring, like 2 or 3 weeks or whatever. Hopefully you've been still practicing. But the first thing we want to look for is a common factor. Do we have a common factor in here?
X
squared. They all have x's in them, right?
Yes.
And not only one x, they all have at least 2 x's. So they all have x squared in them. Does that make sense? So this one has 6 x's, right? This one has 4 x's multiplied together, and this one has 2 x's multiplied together. So if we factor out, we can factor out 2 x's from each of them, and x squared from each of them. Okay? Does that make sense? Okay, so the 0 just stays there. We're working on the right-hand side, so we're going to factor out x squared. And then what we have left here is x to the 4th power minus 3. And we had x to the 4th, so it'll be x squared. And we had 2x
Is it
squared.
plus or multiply?
Hang on. Right here?
Yeah.
That's times.
Times, so why it is become like power x to the power 3?
Say that again. Ask me that again. Why does it become what?
I got it.
Okay. It's good because I wasn't sure what you asked me yet until you asked me again.
Asking if we add the little 2's up there.
Yeah, and remember when you multiply, you add exponents. So when you divide, which is what you're doing, when you factor out, you're dividing out, you subtract the exponents. Okay? Does that make sense to everyone? Okay. So then when we look at this, we've got something that kind of looks like something we've seen before, right? We used to see it with x squared and x and a constant, right? And we did a lot of factoring like that. But this is what we call a quadratic pattern. It looks kind of like what we did before, but the exponents are different. Okay, but here's the pattern. Here's what makes it a quadratic pattern. If this exponent right here is twice as much as the middle exponent, and this is a constant, there's no x's. And so if you think about our quadratics, this was x squared, exponent of 2. This would have been x, exponent of 1. And this would have been a constant. So it's kind of that same pattern. So the nice thing is when we see that pattern, we factor it the same way we did before. Okay? So let's see if we can remember our factoring. Just copying down this front part. I'm just going to, that part just stays there. We're not going to work with it for a while. We're going to work with this part in here. So do we remember what the first step was that we did when we were factoring? Anybody remember? I know it's, like I say, it's been a couple weeks since we actually talked about it in class.
What is the factors or whatever?
You're one step ahead of me. There's one thing we do
plus
first.
or minus.
The first thing we do is this times this.
Wow.
The 1 times the 2. So 1 times 2 is 2. And then we are going to find factors of 2, and we want to look at the pluses and the minuses. So let's look at our signs here. The first sign we want to check out is this one, which is always the same as what's in front of here. And what does that being a positive tell us about the numbers that we're looking for, the factors that we're looking for?
Positive.
It's either positive, positive, or negative,
Yeah.
negative. They have to be the
Okay.
same, right? Because when you multiply 2 positives, you get a positive. When you multiply 2 negatives, you get a positive. So this tells us they're either both positive or both negative. That's what that sign tells us. Then we look in the middle. And since they have to add up to be a -3, that tells us they both have to be negative. Because if you add 2 positives together, like you learned back in like kindergarten, 1 plus 3 is +4, right? You get a positive. And then later on, you learn about negative numbers. And if you add 2 negatives together, your answer is negative. So we know it has to be this one. So now let's write down our factors. Factors of 2. Well, there's only one option, -1 and -2, right? Does that work? Yeah, it multiplies to be 2. It adds up to be -3. So that's the one we're going to use. Now here's where it gets slightly different. Remember we copy this down, right? So it actually is not much different. But we're going to have x to the 4th minus 1. And this is now, remember we're breaking up that middle term into 2 pieces. So it's -1x squared and -2x squared plus 2. Okay, so remember our goal was to break it into 4 terms. And then we want to group them. And all the time, this x squared is just hanging out in the front, just waiting for us to do something with it. Okay, what can we take out of that first half, that first pair? An x squared, because they both have an x squared in them, right? This one has 4 x's, this one has 2 x's multiplied together. So x squared. And what's left in this first term? After we factor out this x squared, x squared, got a lot of x squared sitting there in a row, minus, and what's left in the second term after we factor out the x squared? A 1. And then we close our parentheses. And then again, don't forget this, whatever sign is right here, we have to factor that out. So in this case, it's a minus. And then what else can we factor out of the second group? 2. So we're factoring out a -2. And when we divide out or factor out that -2 from this first term, what's going to be left there? X squared. And then again, when we're factoring out a -2 from the 2, you're dividing it out, it becomes a -1. 2 divided by -2 is -1. Okay. And again, like we said a whole bunch of times a couple weeks ago, if we did our work right up here, these two should be the same. And they are. So that's good. So again, we got this x squared in the front. We're going to take out the x squared minus 1 from both of those. And then what's left after we factor out the x squared minus 1s? X squared minus 2. Okay. So we've done our factoring. We've got everything down to something that's manageable. And I will mention, we could factor this further, but we really don't need to in this case, because our goal is to find the x-intercepts. So if it's broken down this far, we're really in good shape. So does anybody remember, now that it's factored, what we do with the factors? Not combine like terms.
X squared equal to 0.
Yeah, because, and again, remember this, if you've got things that are multiplied together and the answer is 0, one of them has to be a 0, right? So if x squared equals 0, that will make this true. If x squared minus 1 equals 0, that middle term will be 0, and multiplying, that'll make that true. And if x squared minus 2 equals 0, then this term would be a 0, and it doesn't matter what these are, it will multiply to be 0. So the rule that we use is, for that reason, we just take each factor and set it equal to 0, because if any one of them is a 0, the whole thing becomes 0. That makes sense? If you take 0 times 100 trillion, it's still 0. So if this is a 0, the whole thing's 0. Or the whole product is 0. If this one is a 0, it doesn't matter what those two are, it's going to turn to a 0. If this one's a 0, it doesn't matter what the other two are. The whole thing is going to turn to a 0. So these are going to be the numbers we're going to look for that will make this true. Okay? That's our goal. What can we look for that makes this true? And then we just solve these little pieces. So how would you solve this one? X squared equals 0.
0.
Yeah, the only way that's true is, and algebraically, we square root of both sides, you get x equals 0. So that's one of our answers. How would we do this one? This one is 2 steps.
Plus 1.
We have to add 1 first. So x squared equals 1, right? And then we do the same thing. We have to take the square root of both sides. Now, we didn't have to do it with the 0, but what do we normally have to put in front of it when we take the square root of both sides? A plus or minus. Okay, and the reason is this, if you may or may not remember this, but if you take 1 and you square it, so let's say you're putting it in right here. If you take 1 and you square it, that's 1, right? So 1 equals 1, that would be true. But if you take negative 1 times negative 1, if you square that, you also get positive 1, right? So that's why we need the plus or minus, because both of them will make this true. And then for this last one, again, this is a couple steps. What are we going to do first? Add the 2. And then same thing as we did over here, take the square root of both sides, and we get x equals plus or minus the square root of 2. We can't simplify that one. We just leave it as the square root of 2. Can't break it down at all. So if we're going to list our x-intercepts, which is what they asked for, and I know on the computer they get picky about this, so we're going to write it the way they want it. They're going to want ordered pairs. So the first one would be, and remember, it's always going to look like this. So 0, 0, 1, 0, negative 1, 0. So that's these two. And then square root of 2, 0, and negative square root of 2, 0. And all 5 of those would be x-intercepts of that function. And so the work that we do to find x-intercepts is the same as we would do to just solve an equation. Okay? But the thing to remember is, when you look at this, try not to be scared of it. I know it looks scary because it's 6th power. Okay? But look for your common factor first, which we did. We found that. And then when you see this pattern, we talked about the pattern, the quadratic pattern, then you factor it like we did all the other ones that we factored a couple weeks ago. Okay, yeah.
So on the, after we simplified it, or on that, where you, the quadratic,
Here
yeah,
or here?
no, the bottom one. Or is this, yeah, you're right.
This one?
Okay,
Okay.
there, if it wasn't x to the power 4 and x to the power 2, would we still have to have done that?
If this doesn't match up with a quadratic pattern, you wouldn't be able to do that.
Okay.
It just wouldn't work. Now, having said that, the ones that I give you are going to be like that, because if you have a problem like this, I'm going to want you to be able to factor it.
Yeah.
So, but yeah, there are situations in other equations where you won't be able, you just can't. You can't factor. And we talked, I think we talked about a couple weeks ago that some things you just can't factor, and then we have to find other ways of dealing with them. But these, if we're trying to solve something with that large of a power, it's going to be something you'll be able to factor. Because otherwise, we just be kind of. There is a method we're going to learn in the second part of chapter 3, after this test, that we have a method in math that we don't particularly like. It basically boils down to guessing and checking, and we really don't like to do that in math. We just like to have a process and figure it out. But we can do some educated guessing and checking, and we're going to talk about that in the second part of chapter 3. So. But yeah, these will be factorable. Any other questions about that one? All right. So we get our answers there, and we have 5 of them. And let's take a look at this one. So notice this particular question asks for the vertical and the horizontal asymptotes. Now, that just refers to what axis they're hitting. So the vertical asymptotes, since they're hitting this axis, what do you think we would probably call those? What is that? The y. These are the y-intercepts. And we just talked about a couple slides ago that those are always going to be 0 for the x and then some number for the y after we figure it out, right? And then for these, horizontal, that's where it hits the x-axis. So those are the x-intercepts. And I'm abbreviating there. And we just talked about one like that, and that's something comma 0. So the y value is 0. Now, the nice thing about this one is what? It's already factored. We don't have to factor it, right? So don't do anything crazy with it. It's already factored. It's good. All right. So let's say that we're going to find the y-intercept first. That's the easy one. What are we going to do? We're going to put zeros in for all the. I guess these are actually. Okay, they changed the letter on me. So in this case, this would be like a t-intercept. Evidently, they're talking about time or something if they use t. So this would be the t-intercept. And we're going to put in zeros for all the t's. So the idea is we're going to find g of 0, the value of g when we're putting in zeros for all these. And then we just simplify and do the math. So what is 0 minus 2? Negative 2. And that's still squared. And then I think we can do this probably in our heads. 2 times 0. 0 plus 3 is 3. Okay. And then here's where we have to be a little bit careful. What is negative 2 squared? Positive 4, right? Negative 2 times negative 2, positive 4. And then times 3, and we get 12. So 12 is our y-intercept, which means the way we write that is 0, comma 12. Okay. So the y-intercept or the vertical intercept will always be 0 first and then whatever number we figure out. Now for the second one, what do we have to do to find the horizontal or the t or what is usually x's? What do we do to find that one? We put in a 0 over here where we would normally see the y, right? So we're going to have 0 equals t minus 2 squared and 2t plus 3. Okay, does that make sense? Anytime you're finding an intercept, you just put in a 0 somewhere and then do what you need to do. Now, again, we said this one's already factored, so it's going to be fairly easy. What did we just remind ourselves of in example 1? What are we going to do with each factor? Set it equal to 0, because remember, if this equals 0 and we multiply, the whole thing will become 0. So if t minus 2 equals 0, that's going to be a solution. And then the other one is if 2t plus 3 equals 0, that will be another solution. Okay, so the first one is pretty easy. What do we do to solve that one? Yeah, add 2. And t equals 2. So the ordered pair there is 2 comma 0. Okay. And then this one, we've got a couple steps. What do we have to do first? Subtract 3. So 2t equals negative 3. Oh, yes.
Square.
Okay, so that's a good question. So she said, where's the squared? Okay. The squared just means there's 2 of them. So I could write it twice. But do we see what's going to happen both times? Yeah, we're going to add 2. You're going to get t equals 2. You're just going to get it twice. So you don't actually have to write it a second time. You could. You don't need to. Does that make sense? So even if this was a 7, we just write it down one time because they're all the same. Okay. So yeah, that's the squared part, and we're going to actually come back and talk about that in just a minute. How do we finish this one up? Divide by 2. So t equals negative 3 over 2. And if you want to change that to negative 1.5, that's fine. Negative 1.5 if you do it on a calculator. But that's going to be, I'm just going to leave it as negative 3/2, comma 0. So here are our 2 horizontal intercepts. And then here was our vertical intercept. What questions do we have on that? It was the same as the last one, except shorter, but we did have to figure out the vertical intercept also. None? All right. So there's, again, the negative 3 over 2 is the same as negative 1.5, right? If you type it into your calculator, depending on what mode it's set in, it may tell you this or it may tell you this, but either way, it's the same number. All right. All right, let's look at this one. So this one says, find the horizontal intercepts of this function. And we're not going to do it algebraically this time. We're going to look at the graph, right? So where are we going to look to find these horizontal intercepts? Okay, but where did you look to find them? How do you know they're there? Yeah, on the x-axis. So it's just where it crosses. So it's going to be here, and here, and here. Does that make sense? So if we're given a picture, and if I give you a picture, I'm going to make them exact. So if we're given a picture, you should be able to see them fairly clearly. But again, we want to give our answer as ordered pairs. So how would we write this one? Negative 3, comma 0. That's that one. And then this one would be? Right, negative 2, 0. And that's that one. And then this last one?
1,
1, 0. It's just the ordered pairs because they're actually points on a graph, right? And so that's where we would find them. And yeah, that's it. And I'm actually going to add to this one. Since it was so easy, what is the vertical intercept on this one? And where did we look to find that? On the y-axis. So, and it does, if you look carefully, I think it's on your papers too, right? Or is it not on there?
yeah, we have.
Okay. So, yeah. And so you can see that. And what is the ordered pair then for that one?
0, almost.
Yeah, 0 is the x coordinate, and then negative 6. So I could have asked both of those, right? And with the graph, it's fairly easy to find those.
You can give us like 100 of these.
100 of those, and that's
Yeah.
good? Okay. Everybody, but then there will be other people like, no, I like other questions better. Let's take 100 of those. So, but does that make sense if we look at the graph, how we find those points? Okay. And this is one that, again, when we get to the second half of chapter 3, we will be able to figure this out using algebra. But right now we don't, because we can't factor this. We don't have the tools to do it yet. Okay. All right. So -3, 0, which we had, -2, 0, which we had, and 1, 0, which we had. And then we added the bonus question, right? So we
Does it
didn't.
matter in what order?
No, because you're just, it's like making a list. You're just saying, what are they? It'd be like saying, you know, what are the colors on the American flag? You could say it's red, white, and blue, or you could say it was white, blue, and red. It doesn't matter as long as you list them all. Okay? So all right. So multiplicity, which I haven't used that word yet because we hadn't talked about it, but we've actually experienced it a couple times here. Multiplicity is a term that is used to describe how many times a zero of a function occurs. Okay? This happens when there is a repeated factor in the polynomial. So if we go back, not this one, right here, you see how this factor occurred twice? T minus 2 was there 2 times. And when we solved it twice, we got the same answer both times, right? So that means that 0 occurs twice. That's what that means by multiplicity. So we would say in this case, the multiplicity is 2. It's just whatever the exponent is, because that tells you how many times it's there. Okay? So as we go on, I've got a very similar example here. So the zeros of this function, if we found them, we would set this one equal to 0, right? And if you solve it, t minus 1 equals 0, you get t equals 1. And then this is the exact same one that we just did, and we got negative 1.5. So those are the zeros. We've got 2 of them. Those are the zeros. But since this factor is here twice, it's squared, we would say 1 occurs as a 0 twice, and so we say it has a multiplicity of 2. So the multiplicity of 2 since it occurs twice. If I change this to a 7, what would its multiplicity be now? 7, right? Not hard. It's just a lot of these things aren't hard, but when you put them together with a bunch of other stuff, then we start getting mixed up.
What about if we have another power in the second bracket?
Okay, so what's the multiplicity of this one? 7. What's the multiplicity of this one? 3. They each have their own multiplicity.
Oh, yeah.
Yeah.
Not for the
We
whole
don't-
equation.
Oh, for the whole equation, if we were talking about, have we talked about degree yet? I think that's next. I think that's in the next. Have we talked about it? Okay. Have you heard that word degree?
Yeah, it was in our.
Was it in
It's
3.1?
the homework.
Okay. It was in 3.1. Okay. So the degree of the whole thing, I couldn't remember. I was trying to. Anyway, I make those videos really early in the morning, and then I forget what's even on by the time I'm, Anyway, when we look at this, if this one was here 7 times, he had t minus 1 7 times, and this one was here 3 times. And the idea with degree is if we would multiply them all out, you'd have 7 t's combined in this part, and you'd have 3 more t's combined in this part. So altogether, you would actually have 10. I can't put up, anyway, 10. You'd have 10.
Oh, yeah.
And so the degree would be 10, because you'd have 7 from this group and 3 more from this group.
I got that right on that homework. That's how I know.
Excellent. You got it. Okay, so multiplicity, each factor gets its own multiplicity because each factor determines its own 0. The only thing that they might do, and it seems like maybe I saw this on a homework one time, but if they did something tricky like this, and let's say they put that there. Okay, so the multiplicity of t minus 1 is what? It's 9 because for some reason they just listed it twice. We would never actually do this. We would put them together, right? So we would actually just write t minus 1 to the 9th power and then 2t plus 3 to the 3rd power. But first, I think that's just to make sure you're paying attention. I think if I remember on some of the homework, they split it up. Okay, now like I said, that's kind of mean and whatever, but I think I remember seeing that somewhere on the homework. So. All right. If a polynomial contains a factor, like we just saw, where that factor is repeated p number of times, the behavior at the horizontal intercept is going to be affected by that power. Because normally, what have we seen as functions go through? It just like goes through the x. Let me try and say this in words rather than just mumbling. So when we normally see it, the graph just goes pretty much straight through the x-axis, right? That's what happens a lot of times. But if there's multiplicity involved, which means we've got a power, right? At that 0, some unique things can happen. And you can see them on your paper, but here's the options. If the multiplicity is 1, it's just a normal 0 like we usually see. That's what we have been seeing for the last several weeks. It just kind of goes through, almost like a straight line. Not exactly like a straight line, but pretty much like a straight line. If the multiplicity is a 2, where there's a second power attached to something, a factor, then notice what happens. It just comes and touches the x-axis at that point. This is the x-axis, by the way. That's what that's supposed to represent. So it just comes and touches the x-axis and then goes back where it came from. Okay, and that could be from the top coming down and touching and going back up, or it could be also another option is it could be coming from the bottom and touching and going back down. It doesn't have to be on the top. It could also be on the bottom. Okay. And then notice what happens when it's a third degree, a multiplicity of 3, I should say. Notice we get this little kind of an S curve, right? Like if you're driving on the road, you got an S curve. Does anybody recognize this from something we've seen earlier?
The other one, right?
It's one of our toolkit functions. I mean, it looks like one of our toolkit functions. It's the x cubed one, where you've got that S curve going through. And that's because the multiplicity is 3. So it makes it look like at the 0 spot, at the intercept, it makes it look like one of those little S curves. Okay, so if you ever see this, you know the multiplicity is 2. If you see something like this, you know the multiplicity is 3. Now, what can be a little tricky, if the multiplicity is 4 or 6 or 8, it's still going to look kind of like this. If it's 3 or 5 or 7, any of those odd numbers, it's going to still look kind of like this. But but that's what we're looking for. Any of those weird curvy shapes around the x-axis, that tells us there's multiplicity going on. If it just goes straight through, then we have no multiplicity. Just one of them. Okay. So let's see if we can use that information to help us graph this factored polynomial. So what?
My worst nightmare.
This is your worst nightmare, graphing? So, well, here's how we graph. We actually just break down one step at a time, and we've kind of done most of these things. So here's the factors. How would we find, let's start with the easy one. How would we find the y-intercept? Put zeros where the x's are. Exactly right. So it's going to be 0, something, right? So let's do that work. It'll be f of 0. So it's going to be a negative sign, and then 0 plus 1 squared, and 0 minus 2. Now, again, we want to do our work here. 0 plus 1 is obviously 1. And 1 squared is still 1. So we've got a negative, and then we've got a 1. And then 0 minus 2 is negative 2. And when we multiply 1 times negative 2, and then with another negative in the front, what do we end up getting? You end up with, because you've got 2 negatives, you end up with a positive 2. Does that make sense? Okay, so our intercept ends up being 0, 2. So we can put that on here, right? It's just this point right here. Is that so far? Okay, not your worst nightmare yet? Not yet. Okay, good. We've got 1 point. We're cruising. All right, next. Is that the one that's on the bottom and got cut off? I'm sorry. I already apologized for this.
No, you had yours.
Just, put it on your computer. Just draw it with a marker and make a graph there, and or flip it over to the back in the bottom corner or something. Yeah, because the bottom got cut. Anyway, yeah. All right. So if we want to find the x-intercepts, what do we do for that one? Set the whole thing equal to 0. So 0 equals a negative, and then x plus 1 squared, and then x minus 2. Okay? And what do we do with each of the factors now? Split them up and set them equal to 0. So this one, x plus 1 equals 0. And we only have to deal with factors that have variables, right? If there's just a 7 sitting out here in the front, that's not going to turn anything into a 0, is it? Okay, it has to have a variable that we can create something that would turn it into a 0. So and x minus 2 equals 0. So for this one, what do we get? Negative 1. So that is, I'm going to put it over here, negative 1 comma 0. That's going to be this point right here. And then how about this one? X equals positive 2. So that's 2 comma 0. That's going to be this point over here. Okay?
Wait, why is it positive?
Because in order to get this x by itself, we have to add 2 to both sides. Okay? So we've got 3 points. We're still okay. I don't think it's your worst nightmare quite yet. We're still working there. We got to get there sometime. We got to have some nightmares. Otherwise, what fun is it? You know, whatever. Okay. So do you remember? And we're going to find out if anybody remembers from some of the videos where we talked about end behavior. What happens on the far left-hand side and what happens on the far right-hand side. And we don't have to describe it like f of x approaches infinity and negative infinity this time. We just want to know which direction it goes. But there's 2 things we looked at. We had something called the leading coefficient test. And if you didn't watch the video, you probably want to go back and watch the video. But anyway, we had something called the leading coefficient test. And in order to do the leading coefficient test, we had to look at 2 things. We had to look at the degree of the function, and we had to look at the sign of the leading coefficient. That's my abbreviation for leading coefficient. I don't want to write it all out because it's 2 really big words. But looking at this and thinking about what we actually just talked about in our last example, what would the degree of this function be if we we're not going to multiply it all out, but if we multiplied it all out, what would the degree be? No, because, and the reason it's no is because remember there's 2 of these, so the degree would be 3. You'd end up with 2 x's from this group and 1 more x from this group. Does that make sense? Because really what's going on here is you've got a negative x plus 1 times x plus 1 times x minus 2. And we would be multiplying all that out. So if we multiply that all out, do you see that we're going to end up with x cubed? Does that make sense? You just basically have to look at the first part of each one of these and multiply them all together, and that's going to be what your first term is. So it's going to be a degree of 3. Does anybody remember what was important about the 3?
It's the S.
And the reason for that is it's an odd degree.
Yeah.
That it's odd. And so you're correct. He watched the video, I can guarantee that. Okay? So it's an odd degree. And so that means, as far as its end behavior, one side is going to go down and the other side is going to go up. And we don't know which one yet, but one side is up and one side is down, like those odd degree functions. He's like, no, I didn't watch the video, whatever. Anyway,
So is it
I just paid attention.
okay.
odd
Sorry.
number? This is odd number.
Any-
so is it
Anytime it's an odd number, one side will go up and one side will go down. So here are the options that we have. We either have down on the left and up on the right, or up on the left and down on the right. Those are the 2 options that we've got. They have to go one side up and one side down. Okay? That's anytime it's odd. If it's even, they go the same direction. The next thing we look at is the leading coefficient. So again, if we multiply these together, x times x times x, you would get x cubed, but we also have this negative in the front, which is going to turn into a negative 1x cubed. So the leading coefficient is negative 1. What's important about that is it's negative. Okay? And remember what negatives do in the front of our functions?
down?
It makes them reflect. So this is the normal one, right? This is the one we saw all those pictures of x cubed, x to the 5th, x to the 7th, whatever we saw on that one big graph that was all together. This is the normal one, down over here and going up on the right. This negative reflects it. So what's going to happen is now it's going to be up on the left and down on the right. So that means it is this one.
That's really difficult.
Okay, we're getting closer to the nightmares.
We're not done.
Okay, and so here's what that means. With these sorts of functions, basically what we can do then, if we know it's up on the left and down on the right, we can just draw our curve going up here and down here. Okay. Now, the last thing we want to think about, because we are almost done with this, because we got our points, we got our end behavior, we just want to figure out kind of what happens in the middle. And actually, it's probably fairly clear already from the points that we have. But we want to check out our multiplicity. Because remember, that was kind of where this whole thing came from, this example. Remember, if the multiplicity is 1, it just goes through. If the multiplicity is 2, it kind of bounces. I mean, it doesn't really bounce, but it just touches and goes back. If the multiplicity is 3, it does that kind of S-curve. So notice where our multiplicity is. Let's start with the easy one. That one is the 0 at x equals 2, right? That means at x equals 2, it's just going to go through. But what happens for this one at -1? Because the multiplicity is a 2. It comes down and touches, and look, it goes back up. Which kind of makes sense, because where is it supposed to go next? Through this dot, and then back down like that. Okay? If it went through here, we'd have a hard time getting back up to this dot, wouldn't we? Because there are no more zeros to go through. It's like these are the doors, and you can only go through the doors. This one hit the door and bounced off the door, evidently. I don't know. Okay?
I don't know.
You don't know? I don't know either. He didn't open the door. Somebody didn't open the door for him. Okay? So if we know what happens, if we know where the intercepts are, and we know about the end behavior, and we know about the multiplicity of the zeros, the x-intercepts, we can really pretty much get a good picture of what the graph looks like without even looking at a calculator, without doing a whole lot. All we did was we knew these 3 points, we knew the end behavior, and then we went back to our previous slide and said, oh, this has a multiplicity of 2, it's going to touch and go back up. And just from those things, I mean, I could make a huge T-chart too, but I don't really want to do that.
How did you find out the other side of it?
This one? Because if we go back, actually, if we look here, the multiplicity of this one is just 1. When the multiplicity is 1, it just goes pretty much straight through. I mean, it's a little curve, but it just goes straight through. So when we had a multiplicity of 1 right here, we knew it just went straight through.
Okay. So it doesn't matter if it goes like this or down.
No.
Okay.
Like
so we're not thinking
the
about
angle
that.
doesn't matter. It's
Okay.
just that wherever it's going, it goes straight through.
Just straight. Okay.
Yep. Okay. So once again, I will humbly apologize for the failure to put the graph on the paper. All right. So any other questions before we go on from that one? We're on the back page. All right. So we want to consider some inequalities now. We're going to consider these inequalities in light of the graphing stuff that we've just done, which is your favorite. So why are these alarms all going? Are you guys going to leave to go to the thing? Is that the deal?
Oh, mine.
I just hear alarms all over the place. It's not 7 o'clock yet, I promise. Okay. So,
Is it? No, it's your computer, maybe. It's your computer.
is it my computer? I muted my computer. It can't be that.
An alarm? Do you have an alarm? No.
Okay. So, anyway, it's my imagination. You guys don't hear it, do you?
I did hear. Maybe your wife called.
Okay, what we need to do is we're going to draw a graph here. And this graph is going to be very non-specific. We just need to know a couple of things, because our goal in this problem is to figure out when do we multiply all these things together and have them be greater than 0? Right? That's what that means, greater than 0. See, that is not my computer. That's coming from back there somewhere. I'm not imagining this. Okay. So the first thing we want to do is find the zeros. What 0 will we get from this factor right here?
-3.
Does that make sense? -3. X equal. If we set this equal to 0, we're going to find the way we find the boundaries where the zeros are is we set it equal to 0, right? Okay, and it's already listed as greater than 0, but we're going to find the boundaries to see when does it equal 0. So x equals -3, which means -3 comma 0. So 1, 2, 3, there's one of our zeros. And this can just be a sketch because again, it's not going to be very accurate. We're looking for a general picture. What about this one? If we set this one equal to 0, what would we get? X equals -1. So -1 comma 0. That would be right here. And how about this one? If we set this one equal to 0, what would we get there? X equals +4. So 4 comma 0. Okay. Now, can anybody tell me what part of the graph would we consider greater than 0 and less than 0? Now we got to be careful here because this is our function, and so we're talking about
4.
we're talking about like our function value is greater than 0. So when we're talking about greater than 0, we're talking about the top. We're talking about y values, right? When are these values, when we put them all together, when is the output, the y value, greater than 0? Or less than 0, depending on the problem. Okay? So we're actually almost done. It doesn't look like it because we've only got 3 dots, but we're actually almost done. Let's look at our end behavior. What is the degree of this function if we would multiply it out?
Y's value.
We have to, it looks like x cubed, but remember we got a 2 there. So we actually have x to the 4th power. Because you've got, if you think about what it is, it's x plus 3, x plus 1, x plus 1 again, and x minus 4. Does that make sense? There's 2 x plus 1s. So you have 4 x's that you're multiplying together. So our degree is 4. And what's important there is that it's even. And what did our family of even functions all look like? Normal. They look normal. What they all looked like this. You know, they had some different flatter bottoms or more rounded bottom, but they all looked like that. X squared, x to the 4th, x to the 6th. Okay? So we know it's going to go the same direction. That's what this tells us. So they're either both going up or they're both going down.
Yeah, all the even ones will look like that. So 2, 4, 6.
Okay? Does that make sense? Because if it's not reflected, it looks like that. If it's reflected, it goes down. So what is our leading coefficient in this case? If we would multiply these all together and look at the number in the front, what would the number in the front be? So okay, but okay, I have to okay, let me preface this. Remember what we're looking at? We're looking at the number in the very front. We're looking at the leading coefficient. The leading coefficient comes from x times x times x times x. That's where you're going to get your leading coefficient. And so what's the number that's in front of x times x times x times x? Yeah, it's you don't see it, but it's a 1, right? We don't write it down because we know it's there. So it's a 1, and that is positive. So which of these 2 options is it? Is it the normal one or the reflected one? Normal. It's this one. So we know over here, up, over here, up. Okay, is that good so far? Now the only other thing we have to look at is our multiplicity. What happens at -3?
You mean 3?
No, at -3.
Oh.
Is it going to go through or bounce? And how do we know? I'm going to ask you both questions, so you better be ready to answer both. Does it go through or does it bounce?
What do you mean?
It does not bounce.
It does not bounce. That's true.
I don't know why.
Why
I'm
not?
gonna ask you that question, but why?
Oh.
Remember? Does it go through or does it bounce? That's what we're looking at here, the multiplicities. So now that we know, what happens at x equals -3, what happens for this one? And I already gave it away because she said it bounced and I told her she was wrong. So it goes through, right? But why? Why does it go through?
It's negative.
It's less than 0.
Actually, neither of those. Go back. Here we go. I want to make sure we get this.
It's
It's because the multiplicity is 1,
Yeah.
right? Do we see any exponent on this factor?
No.
So it's automatically a 1.
Oh.
And if that multiplicity is 1, it just goes through.
Oh.
Okay? Does that make sense? Okay, I'm not trying to embarrass anybody. I just really want to make sure we get it so that we understand. Now let's do the other easy one, hopefully easy. This one, what's the multiplicity?
1.
1. So what's going to happen when x is 4? It's just going to go through. Okay? Now this one has a multiplicity of 2. What's going to happen here?
Gonna bounce.
It's going to bounce. It's going to touch and go back. So it's already down, and it's down over here. So it's going to come up and touch and go down like that, right? I mean, we don't really care. We just know it goes back down.
Oh.
Okay? So the question that this is asking, the question that we're trying to do is, when is our graph greater than 0? And I already mentioned this. What part of the graph are we looking at to find greater than 0?
The Y.
The y. And so we're talking about the top half of the graph, right? It's greater than 0 over here. Here it's negative. That's less than 0. Here it's 0, not greater than 0. Here it's negative, less than 0. And then once we get back over here, greater than 0 again, right? So we have 2 areas, 2 intervals that are going to make this inequality true. So back to interval notation. How do we write this one in interval notation? Because it would be everything from here and then this direction, right?
Negative infinity.
And we have to be careful on our order. The negative infinity does have to go first because it's the furthest to the left. And then all the way up until -3. Infinities always get parentheses. What will this one get if we're dealing with just greater than 0? Parentheses. When would it have a bracket? If there was an or equal to sign here, then it would get a bracket.
No.
Okay? And we're going to have an example like that on the very next example that we do. So you're going to see it. And then we've got another area right over here. How are we going to write that one? 4 is the lowest, and then it goes forever to infinity. Okay? And infinities always get parentheses. And what does the 4 get? Parentheses, again, because of this. It's just a greater than. So parentheses. And so that is our answer. Now, again, we didn't have to draw a really careful picture of the graph. We just needed to know where was it above the x-axis, where was it below. Right? Because
So
above is positive, below is negative.
On that one, you don't use the middle.
On that one, we didn't even care about the y. I mean, we could find it if we wanted to be more specific, but it doesn't matter to us. We just care about above or below. Okay.
If it just passes a point, it doesn't matter.
All right. Let's try. This one is probably a little easier, but hopefully anyway. So there's our answer. Or maybe it's harder. I don't know. We're going to find out.
Hard.
All right. So let's look at the question. The question says find the domain. Now what? Oh, just don't look at that answer. Okay. That's not even the right answer. I just know that already. I'll tell you why in a second. Okay. So find the domain. So what is it? What's the domain? We've used this word before. What does domain mean?
X.
It's X, or it's the input values, right? So they're saying, what values are okay for us to put into this function? Now, what creates possible problems for us in this function? Because usually we just kind of put in whatever we want, right? Do we know? Does anybody remember what happens with a function like this that creates problems? Okay, so we're going to learn something new. It's this right here.
Oh.
The radical sign, the square root sign. Because can we take the square root of 4?
Yeah.
Yeah, it'd be 2, right? Square root of 4 is 2. Do we know what square root means? Yeah, I type it into my calculator. That's what it means. Okay, but it means like the square root of 4 is 2 because 2 times 2 equals 4. I could say the square root of 9 is 3 because 3 times 3 equals 9. I could say the square root of 1 because 1 times 1 equals 1.
16 is 4.
16 would be 4. Square root of 16 is 4. But can we take the square root of like -4? Is there a number that when you multiply it by itself, you can get a negative answer? No real numbers. So this symbol right here means that whatever's inside of here has to be positive, or it could be 0, because the square root of 0 is 0, because 0 times 0 is 0. Okay, so whatever's inside of here has to be greater than 0, positive, or it could equal 0. So that's how I know this answer is wrong, because what we're going to write down is the stuff on the inside, whatever it is, in this case it looks like this, the stuff on the inside, in order for it to work for the domain, has to be greater than or equal to 0. Okay? So, this is a quadratic. It has a degree of 2, right? But it's written in the wrong order. I don't like that. Let's switch it around so it looks normal to us. And that means we would put which one first? The negative t squared, because we want that to be first. And then the minus 5t would go second, and then the 6 would go last. Is everybody okay with that? We just rearrange the order? Okay. Now, this looks like something that we might be able to factor. So we're going to actually have to do the work this time. But the first thing is, do you remember that we don't like this t squared to be a negative? How can we deal with that? And in this case, it's not an equation, so we just factor out a -1. And that leaves us with, again, we're dividing, right? When we divide out a -1, we have t squared plus 5t minus 6. Does that make sense? All the signs just change when you divide by -1. Like 7 divided by -1 is -7. -2 divided by -1 is +2. The signs just change. And that's what we did there. So we've got this negative in the front, and now we can work with this. So let's go through our steps of factoring so that we remember our steps of factoring. First thing is this times this. So 1 times -6 is -6. Now, we did it before. What are we going to look at next? The fact that this is negative. Now, the last one we did was positive. But what does it mean that that number is a negative about the signs of the numbers we're looking for? Positive, negative. If you multiply two numbers together and you get a negative answer, one of them is positive and one of them is negative. That makes sense? So 1 positive, 1 negative. Okay? Then we still look at this middle sign. And what does this sign tell us now? The bigger one's positive, because when you add them together, the positive one outweighs the negative one. Right? I guess I do that backwards. It's bigger than the negative one. Okay? So the positive one is going to be the bigger one. So when we start writing down our factors of -6, the first one I would always look at is 1 and 6. And we know that the positive one is bigger, so -1 and +6. And that one works right away, doesn't it? Adds up to be 5. So let's go ahead with our factoring. -1. I'm going to put a bracket here just so the -1 stays out. And we're going to write down what? You guys tell me. T squared. Yep.
Minus 1t.
Minus 1t. Perfect.
60.
Correct.
Minus 6.
Yep.
Parentheses.
Yeah, and I used a bracket just because of what we're going to see in a minute here. But then once we see that, we've got 4 terms, and we do what with them? We split them into groups. So first group, second group. And my -1 is still out here in the front. What can we take out of the first group, the first pair? A t. And what's left inside the parentheses? T minus 1. Correct. Now we have to take out whatever sign that is. In this case, it's a plus sign. What else can we take out from the second group?
6.
A 6. And what's going to be left when we divide out the 6? T minus 1. Okay. Now that means they're the same. We can take out the t minus 1. And what else is left after we take out the t minus 1?
T plus 6.
T plus 6. Okay. So now we've got it set up with factors. Let's look at what our picture would look like. So what 0 would we get right here? Because remember, we would, to find the boundaries, we would set it equal to 0. So if we set this one equal to 0, what would we get? Positive 1. So positive 1. Okay. What would we get for this one? Okay. Is everybody okay with that? Or do I need to write it down? Like write it out? Because we're just setting each factor equal to 0. Okay, so 1, 2, 3, 4, 5, 6. Okay, that's not very good spacing, but whatever. And then what's the degree of this? We actually know from the very beginning. What's the degree? I mean, that's where remember the degree is the highest power. So the highest power is 2. So what does it look like normally? Since our degree is 2, what does that make it look like? What are the options? Or what's the normal? What does it normally look like? Yeah. And actually, this is a parabola, right? It's x squared. She's giving me signals here. So the degree is 2, which means it's even. And that means it looks something like that. So it either goes up on both sides or down on both sides, right? And with our negative in the front or negative in the front right here, what do we know about our leading coefficient? It's negative. So our leading coefficient is -1. So it's negative, and it is going to be this option, which means here and here, it goes down. What's the multiplicity of both of these? I mean, individually. What's the multiplicity of this one?
1.
1. What's the multiplicity of this one? 1. And what does that mean about our graph?
It doesn't.
Just goes right through. And eventually, because it's a parabola, right? It goes down. So what do we need?
I have a question.
Yes.
On the other example that you did, the degree
last one?
was 4.
Yep.
But it has the same
Yes.
square.
Yep.
This one has the same square, but it's 2.
Yeah. Yep.
Why?
Anytime it's even. So if the degree is 6, or the degree is 8, or 2 or 4, or 712, they have the same. Anytime this degree, the power is even, then you've got either both going up or both going down. Is that what you're asking, or not what you're
See
asking?
how on this one it has the 2,
Oh.
and then the degree is 4.
Oh,
Because
okay,
it has-
okay.
And this one it has the same.
Because we have to put them all together. So notice here, there's no factors, right? It's just written out. Once we factor it, it looks like this, and there's 2 factors. If we multiply them together, it would be squared, right? Because, I mean, we broke it up into factors. So when we break those up into factors, it's squared. But if it was written out, it just looks like this, t squared. This one is factored already, but if we multiplied it out,
Oh,
it would be x to the 4th.
Oh,
Does that make
okay.
sense? Okay. Okay, so to finish this up, we need this to be greater than or equal to 0. Where is that? On the outsides or in the middle? It's in the middle. This is the positive area, right? So what are these boundaries? -6, +1. Okay? Which, that's fine. But why is that wrong?
Oh, that's
Because that one has or equal to, right? Which means what about our symbols? These should be brackets. So that's when you should see the brackets, is when you have the or equal to. Okay? So that's the difference. If there's no brackets, or if there's no or equal to, it's parentheses. If there's the or equal to on the bottom, then it's brackets. Front page so we remember it.
So if
Okay.
this come with that kind of questions, we have to draw a graph.
I would, because it's just easier. I mean, there are ways you can use to solve it. What?
We make a number line.
I suppose you could do that too. You mean like just put in values and check?
No,
that what you're saying?
like this. With the same answer.
So you did each one individually,
And then.
and you're just looking at the product of the two?
Uh-huh.
Yeah, that's the other way to do it. You can do it that way.
So that's
But I used to teach it that way in the high school, and they always got confused when I did. So they visualize, they see the picture easier, it seems like. And so different people are going to see it differently.
Last semester we learned like that.
Did you?
Yeah.
Okay. Us last semester?
Uh-huh.
We did it that way?
Yes.
Oh, okay. All right.
Right. Last semester we did that. We draw a picture. And then like.
Oh, yeah, I think we did.
Yeah.
All right, well, you know, you get yourself a well-rounded, all the different options. Okay, writing equations. So write an equation using intercepts. we've already been going from factors to the graph. So in this case, we're going from, we're done. All right. It's 7 o'clock. I got to stop, right? 7 o'clock is when we're done. Okay. So I would check out the video on this lab. There's one more example here. Check out the video on that one. Okay. So here's what it boils down to. If this is a 0, right? We can see there's a 0 there. What's the factor that goes with it? The factor would be x minus 2, right? Remember how we would solve x minus 2 and we would get 2? What's the factor that goes with this one? X minus 5. What's the factor that goes with this one? X plus 3. And you can see those factors down here. Notice this one, it bounces. So its multiplicity is 2. Okay. Now the way you get this 1 over 30 in the front is you write down these factors, x plus 3, x minus 2 squared, and x minus 5. And then you pick one other point. I would say that one's probably the easiest one to pick, the y-intercept. So that point is 0, negative 2. And just like when you plugged it in on your lines to figure out the b value, the intercept, you're going to take the negative 2. And we have the possibility of this a value in the front of all these factors. Okay, and that one's squared. And so what we do is we'll put in zeros for all of these. And all you'll have left is a bunch of numbers with the a and get the a by itself, and that ends up being 1 over 30. So I would, if you want to see that more specifically, because I know there are probably questions like that on the homework, check out the video and I'll have it posted and you can find that. So, but there's 8 problems from that assignment.